Okay, so in this video I'm going to talk about the normal distribution table and how to use the table to calculate probabilities. In a previous video we looked at the heights of people and we found that heights of people were normally distributed, and we looked at a mean of 170 centimeters and a standard deviation of 10 centimeters. So this is how you would write it. This just means that our variable, in this case heights, are normally distributed, so they would make a normal curve if you were to plot them. The mean is 170 and the standard deviation is 10. So when we convert that to our standard normal distribution, we would write it like this. Our mean would be 0 and our standard deviation would be 1 when we convert from actual x values to z values. Okay, and we use the the formula z is equal to our x values minus our mean divided by the standard deviation. We looked at how many times the standard deviation divided into the difference between any x value and the mean. So how far our x value was from the mean, basically. How many standard deviations it was from the mean. Okay, so what we're going to do is I'm just going to take a particular problem here. We're just going to say let's take the probability that our z-score is less than or equal to 1.3, for example. So we want to know what the probability is that our data point will be less than or equal to 1.3 standard deviations above the mean. So if we were to draw that, for example, we would have something like this. We would have our normal curve. This is our mean here, down along here, and this would be 0 in this case because this is the standard normal curve, and we're looking now at 1.3 here, which is roughly, let's say here, 1.3 standard deviations. It's plus 1.3, so we're talking about above the mean here. So really what we want to know is what's the probability of our height or our weight or IQ scores or whatever it is we're talking about that's normally distributed. What is the probability of being less than 1.3 standard deviations above the mean? So we want to know what's the probability of our point being down here, of any point being down here somewhere. Is it, are we 90, or is 90% of the data down here, or 80%, or 85%, or 5%? How much of the data is down here? So let's see how we would actually go about doing that. Well, we need to use our normal distribution, our standard normal distribution table to do that. So let's have a look at what that looks like. So I have one here. This is the normal distribution table as it appears in the maths tables or the log tables. Down along here you've got your z values. It goes from 0 down to 2.9, and these are the decimal places then, if you like. So it goes from 0.0 down to 2.99. 2.99 is right here, so 99.86% of the data will be less than 2.99 standard deviations above the mean. Okay, so what we're going to do, we're looking at 1.3 anyway, so we go down along here. Here's 1.3 standard deviations above the mean. So our value here is 0.9032. 0.9032. So our value here is 0.9032. So the probability of being less than or equal to 1.3 standard deviation somewhere down along here above the mean is 90.32%. You've got 90.32% of a data point being down along here, less than or equal to 1.3 standard deviations above the mean. Okay, so let's look at another problem here. Let's say we want let's say the probability of z being less than or equal to minus 1.3 standard deviations. Now minus 1.3 standard deviation is going to be below the mean. So if we were to draw that again, we've got our normal distribution curve here. So let's just draw that again. It's going to look something like that. We're going to have our 0 here. Whoops, our 0 here. Let's just cross that out. We have we'll put in a 0 here, and we're looking at minus 1.3 standard deviation. So we're looking at being somewhere down here. Okay, so minus 1.3 standard deviations. Now the tables themselves will give you the probability of being less than whatever your z value is. So you're always looking at the left hand side of this line here, or this line here in this case. So what we really end up looking for is the probability of being in this area here when we actually read the tables. Now the tables in the maths tables, or the values in the maths tables or the log tables, are only positive. So what we've got to do is look at the fact that this normal curve here is symmetrical. So in other words, if we have a look at this part up here, say we go up to 1.3 plus 1.3, this area here, this area in here is exactly the same size as this area here. I know it doesn't look like it on this particular diagram, but that's just the way I've drawn it. But it is in fact this area, because this graph, this curve is symmetrical, this area here will be exactly the same as this area here. So if we find the probability, we want to find this, that z is less than or equal to minus 1.3. But let's say we take, we look for the probability of z being less than or equal to 1.3. That will give us all of this area down here. We know that the entire curve would, underneath the entire curve, the probability of being underneath the entire curve is 1. So all we need to do is find 1 minus the probability of z being less than 1.3, and that will give us this area here, which is exactly the same as this area here. So this part of the calculation here will give us all of this area down along here, the probability of being in this area. We've already done that here, in fact. So 1 minus that will give us this area up here, which it happens to be exactly the same as this area here, because the curve is symmetrical. Now we've already worked out this part here. We've worked it out as 0.9032. So in fact this just simply becomes 1 minus, so this is equal to 1 minus 0.9032, which becomes 0.0968. So this here is the probability that a data point will appear in this area here, which is exactly the same as this area here. So the probability of z being less than minus 1.3 is 0.0968, or just simply 9.68%. So there's 9.68% chance of a data point appearing in this part here of your normal distribution. Okay, so that's two examples. Let's have a look at one more. Let's say we're asked then for the probability that z is greater than or equal to minus 1.3 and less than or equal to 1.3. So what would this means? Let's see, we'll just draw the normal curve first of all. So let's see, we'll do the same again here. We'll draw the curve. So we're looking at your usual curve here. We've got 0 here, the mean here. Now what we want in this case is we're looking for minus 1.3, so we just draw in minus 1.3 here minus 1.3 standard deviations, and we're also talking about plus 1.3 on this side. So what we're looking for is the probability of our heights or our weights or whatever it is, the probability of being in this particular area here, right in the middle. Okay, so we've got to calculate the probability of, or the amount of data, or the probability of the data being in this area here, less than 1.3 standard deviations above the mean and greater than minus 1.3 standard deviations below the mean. Okay, so how do we do this? Let's have a look at that then. Okay, so first thing we're going to do is, what you should really do when you're answering any of these questions is just draw a rough sketch like this and just shade in the area that you're actually looking for, like here, and in this case between minus 1.3 and plus 1.3. So draw a little sketch first. So really what we're going to do is we're going to use the tables to find this area down here, all of this area down here. Remember, the tables will give you the probability of being less than 1.3 in this case, so all the way down along here, the probability of being in this area here. Then we're going to find the probability of being in this area here, and then we're going to subtract those two values, which will give us the value we're looking for in the middle here. Okay, so let's do that. So we're looking for the probability of going from minus 1.3 less than or equal to z less than or equal to 1.3. So this is what we're looking for. Now, what we need to do here is look for, first of all, the probability. This is going to be equal to the probability of z being less than or equal to 1.3. So this part here, if we calculate this, this will give us the probability of being down along here, this part of the curve here. In other words, this part here, if you like, yeah. So it includes this blank part here as well, all of this. Now we want to subtract the probability that z will be less than or equal to minus 1.3. So we want to subtract, this part here gives us all of this. This part here will give us this little bit here, this blank bit. So we subtract the two, and that will give us the bit in the middle here. So let me just write that out again. This is the probability that z is less than or equal to 1.3. We want this part here now, as we've seen up here, is going to be 1. Just put a bracket here, 1 minus the probability that z is less than or equal to 1.3. Remember to calculate this part here. This part here is just this little bit down here, and to calculate this, what we're going to do is calculate the probability of being up here, which, as we've seen from this part of the question, is just 1 minus the probability of being less than 1.3, z being less than or equal to 1.3. So this bit here we've already done up here. Okay, so this entire thing here is what we really need to calculate. So we've done some of this already. So the probability of being less than or equal to, z being less than or equal to 1.3 is 0.9032. This part here we've calculated up here already. 1 minus, so it's going to be 1 minus 0.9032. That's this bit here, as we've already calculated here. It's the same as this here. So it's 1 minus this. So let's just move this up a little bit. And here we end up with 0.9032 minus 1 plus 0.9032, and when you calculate that, you get 0.8064. So the probability of z being greater than minus 1.3 standard deviations below the mean and less than 1.3 standard deviations above the mean, in other words, or any of our data points being within this area here is 0.8064, or you have 80.64% chance of your data point appearing within here. So whether we're talking about weights or heights or whatever, 80.64% of the data will be within these two standard deviations here, minus 1.3 standard deviations plus 1.3 standard deviations.